Today I'm going to show you how to create this slime alien creature that's going to randomly crawl around your scene with simulation nodes in Blender. And by the way, if you want to have this Blender file, you can find it on my website MTR Animation, where you can find all the Blender files of all my videos. And with that being said, let's get started with the tutorial. So for this tutorial I created this little parkour thing that our creature is going to crawl around in. I'm also going to import an empty, so if you do Shift A, empty plane axis, I can put that over here, and that's going to be our beginning position for our creature. Let's also press Shift A and add in a cube, and the cube is going to be the object that's going to have the geometry nodes on it. Oh, and by the way, the UV spheres that I added in as the parkour, I created a target collection for that. If you want to do that as well, you can click on all the UV spheres, you can do M and then create a new collection or put it in your target collection. And the empty and the cube, I just put that in the default collection. Let's maybe rename this empty into beginning position. From here, let's go into geometry nodes and let's click on our cube and let's click new to add in a new geometry nodes. And let's name this geometry nodes like feature, something like that. Let's start by deleting the group input. And then what I want to start with is Shift A, add in a points node. If we connect this with the group output, then we can see a point right over there. I want that the position of this point is always the position of the empty. So let's in the geometry nodes, let's drag in our beginning position like this, and then let's put the location of the empty into the position of the points. And you will see the point starts over there. From here, we're going to start simulating. So let's press Shift A and do a simulation zone. Let's connect the points over here, and let's connect this one over there. The first thing that we want to simulate is that on this point, every few frames, a new curve is added in. And we can do this by first clicking on the simulation input. Click N to make this pop-up open and name this geometry point. Now on this point, I want to instance a lot of curves. So let's press Shift A and do an instance on points nodes. And as the instance, I want to do a curve line node and connect that like this. Now if you press play, you will see nothing will happen, or at least it looks like nothing is happening. The instancing that we are doing, we can better visualize this if we randomize the rotation with a random value node. So if we click that over there, then you will see it starts glitching, right? It's not good. That's because when you do it like this, it's like, okay, the one point streams into here, it instances one curve, and then it goes like this. But then when you simulate this, it goes back to here, and over here there's like a curve, and it instances a curve on that curve, and then a curve on that curve, and then a curve on that curve. I want that this stays one point. So what I want to do is creating a second geometry socket in the simulation input. So click on the simulation input, click on this plus icon, and name this curves. And I think it would be good if we put these curves on top of the points. Let's move this part a little bit like this, and let's connect both curve sockets with each other. And I want that on this curve connection, the instances should be joined. So if we do a join geometry, and we place that over there, join the instances like this on the join geometry. In this, it is very important that the instance on points is below the main line of the curves. So keep it like this. We can disconnect the instance on points from the points node, and we connect this one like this so that the point stays the same. It's just cycling. And now you will see if you press play, nothing really happens. We only see the point. That's because we have only the point connected with the group output. We also want to connect the curves with the group output. Then you see nothing is really happening. That's because the random value is always the same. If we do a scene time and we can connect frame with seed, then you will see every frame we're getting a new placed curve. I don't want to add in a curve like every single frame. I want to add in a curve like every 30 frames, for example, whatever you like. To do this, we can add in a scene time node and also a math node, which we set on wrap. Because with the wrap node, we can literally say, okay, every 30 frames we put one in. If you connect frame with value, we can set the maximum value to 0. And if you set the minimum value on 30, then you're basically saying every 30 frames we want to add in a new curve. If we now also add in a compare node and we set this on integer and also on equal, we can say, okay, if this value is equal to 1, so if it's every 30 frames, this one will be done. Now to say that a curve should be added in every 30 frames, we can add in a switch node. We put that over there and we connect as the switch, we connect the result. A curve should only be added in when it's every 30 frames. So when it's true, it should be added in. And if it's false, it should just stay the same. So like this. Now if we press play, you will see every 30 frames a new curve is added in. Now that we've done this, I can remove the randomness for this because we don't need it anymore. So I will remove the random value and the scene time over here. I also don't want that the end parts of each curve starting like with a little bit of an offset. No, I want those end parts to be started from the middle of the empty. So in the curve line, I make the Z end, I make that 0. And then you will see it looks like nothing is happening, but that's because the curves are now infinitely small and then you cannot see them, but it is happening. Let's take all of this and move it a little bit down and let's press Ctrl J to put a frame over it. And as the label, let's name this add in curve every ... frame. The end parts of the curves that we've just added in should randomly go to like points on these UV spheres. And we have to create those points that it should randomly go to. So let's do this by adding in a distribute points on faces node. And as the mesh, I'm going to use the target collection that I created earlier. So over here in the collection, we can just drag in our target collection right over here. In the collection info node, we set it on relative and separate children. And now it's seen as instances. I don't want this. I want to realize these instances so that we can actually do something with the actual geometry of these. Connect this with mesh. And then if you click Alt, Shift, click, then we can see the points that we can go to. We can make the density a little bit higher, like 100. For each new curve that we are adding in, I want to choose a random point within these points to go to. To do this, press Shift A to do a sample index node. Set this from float to vector because we want to get the position of each point. And to choose a random point, we can use this index over here. So if we do a random value node, we set this from float to integer. We can put the value of the random value into the index, and now we're choosing a random index, or in other words, a random point between 0 and 100. There are more than 100 points over here, so it wouldn't choose all of the points, but I want this. I want this max value to be the maximum number of points that is scattered around over here. To get this, we can do an attribute statistic node, place that over there, and the geometry is going to be these points, and the attribute that we want to capture is the index of each point. Connect that like this. Now we have the maximum number of this index, and we connect that with the max value, and now all the points are included in choosing a random point for each curve. Also add in a position node, of course, and connect this over here so that we get the position of that random point. Now to move the endpoint of each curve to a random point, let's connect the curves output over here again. And I want to do a set position right over there. And the selection in the set position should say that it only counts for the end position of each curve. So let's do an endpoint selection. Make the start size 0 and put the selection into selection. Now to make the endpoints go to a random position that we capture over here, we have to say, okay, take the original position of the endpoints and subtract that with a vector math node from the random position that we chose. So connect that like this. And then if you put this into the offset of the set position. Now if you press play, you will see nothing is happening. That's because these curves are still instances and we have to realize those instances. So let's do a realize instances node right over there so that it will actually happen as you see. Every 30 frames a new curve is added in and it will point towards a random position. However, at the moment it goes like instantly. I don't want it to go instantly, I want it to go traveling to there. For that, we add in another vector math node and we place it after the subtract node and we set it from add to scaling and then set the scale on 0.1 for example. And then you will see it will start traveling to it. I will set the scaling on 0.5 actually, so that it goes a little bit fast. Just for the sake of this part of the tutorial, let's make the minimum value over here like 4, so that more curves are adding in faster, so that we can see more results. And then when we press play, this will happen. Okay, that's good. Keep it rolling for some while. Okay, when you press Alt Z, you will be able to see that some curves are choosing points that are actually not really visible from over here. And that makes it that some curves are going through the objects. Let's fix that. Let's fix it that it will only choose points that are visible from here. And we can do this by adding in a raycast node. And on the raycast node, basically what it will do is from this point, it will shoot out a lot of rays. That way it will be able to filter out the points that are not visible from this position. So in the raycast node, the target geometry is going to be our collection. So put the realize instances into the target geometry. The ray direction is going to be the direction from each point to this point. So we can get this by adding in a geometry proximity node, connect that with the realize instances like this, and then press Shift D to add in another one. And with this one, we want to get the position of the point like this. We have to set this on points if we want to get the location, otherwise it won't work. Now to get the vector data that goes from here to every other point, we want to subtract this one from this one. So let's do a vector math node, place that like over there, kind of like this. And let's set this on subtract. And then let's subtract from this position, let's subtract this one and put this as the ray direction. Now if you do Ctrl Shift click on the raycast node and Ctrl Shift click on the distribute points on faces, you will see it already starts working, especially when you move around the empty. Oh, you see, oh yeah, when I click on the empty, everything is gone. If you don't want this, you can in the geometry nodes turn on over here, and then you can just click on the empty and move it around, and then you see some parts are already working. But let's make this better with the source position. The source position is going to be the position of our faces that we have over here. But we cannot just put it like this in it, because then nothing will change. To make the filtering out go better, we have to add in a vector math node, place that over here, and we want to add to this position this subtract node. But this looks pretty weird. That's because we also have to normalize this subtract node. So let's press Shift D on this one, place it over there, make it normalize, and then we want to scale this down by a lot. So let's do Shift D again and let's put it over there, set it on scale, and let's do scale by 0.0001 like this, and then you will see it works. Every point that is black is visible from the empty, and every point that is white is not visible from the empty. And this way we can say, okay, delete the white parts and keep the black parts. Let's remove the viewer node, we don't need it. If we now do Shift and we hold down our right mouse button to make like a connection point over here, we can, with a delete geometry, we can put that over there, and as the selection we do the is hit over here. And then you will see we're only keeping the ones that are actually visible from this point. And now if we connect the curves again with the group output, and then we see when we press play, it starts working again, and you will see there's no curve that goes through our objects. Let's now make it that after like 10 frames or 30 frames that each spline has been alive for, that the endpoint goes back to its original position. To do this, we want to track the age of our curve. And to track the age, we can go into the simulation input, go over here and click on the curves, then click on plus, because we want to have the age value below the curves. This age value should not be geometry, of course. We want to make this integer. And to keep track of the age, we can go over here and do a capture attribute node right over there to capture the age every frame. Set this from float to integer, and as the value I want to connect this age value right like this, and then also connect this one with the age. Now we want to add 1 every single frame so that the age goes up with a math node. Set that like this, and we want to add 1 every frame. And then if we add in a compare node and we set this from float to integer, if we connect the age with a and we set the b on like 30, we can say like after 30 frames, put it back to its original position. If we put this one right over there, we can move this a bit out of the way, and then with a switch node, we can set this from geometry to vector. We set that like this. We can say, okay, if it's greater than 30 frames, then it should go back. So the true value is what should happen after 30 frames. To calculate that it goes back, we want to do a geometry proximity node. And we set this from faces to points because we want to have the position of that point. So if we connect the point with that target, then we have the position. And now over here, we already have a position node, so we can reuse that. If we take this subtract node, Shift D it like this, we want to get the position of each endpoint and subtract that from the position from the center point. And we also want to scale this down. So let's take this one, Shift D, put it like this, connect it over here and connect it with the true value. And now you will see that after 30 frames, it will go back to its original position. Let's make it that we can see both the point and the curve. So let's do a join geometry right over here and also connect the point with that we can see the point. Now this point, I want to make it that the position of this point is always the average location of each curve. To do this, let's do a set position over here on the line of the point. And to get the average position of each curve, we want to do an attribute statistic node. And as the geometry, we take the curve geometry right over here like this. And I want to set this from float to vector because we want to get the position of it. And then if you do a position node, we can set that to the attribute like this. I want to make it that the position of this one is always the mean position of the curves. And now if you press play, that does work, as you see. However, the curves start tripping a little bit. That's because the beginning parts of the curves are not following this point. So let's make that happen with another set position node on the curve line over here. So let's do a set position, and this one should only control the start size. So let's take this endpoint selection over here, Shift D, put it over there, and let's make the start size 1 and the end size 0. And let's connect selection with selection. And to make it go like always to that point, we already have that little system. We created that with the end size position over here. Let's take this position node, this geometry proximity, the subtract and the scale node, and let's Shift D this to here. And this is basically saying, okay, it should go always to that point. So if we connect this one with this, then it should be that it's tripping. Of course, it will be tripping like this because in the geometry proximity node, I don't have a target. I want to have the target to be the points. So let's take this point value and drag it over to the geometry proximity over here. And you will see it kind of works. It's still a little bit trippy. That's also because we don't have to scale this down. So let's remove the scaling node over here. And you'll see it does work. However, it's still tripping. That's because now, since this point is like moving around, these points, these deleted points over here are always changing because they are dependent on like the position of that point. So I want to make it that once the direction of the start point of each curve is set, it should not change anymore. No matter which point is there or whether it gets deleted or something. So it should not change anymore. We can do this with the age of each thing. So if we take this whole thing and we make a little bit more space like this, we can add in a switch node right over there and also a greater than node right over here. And let's also do shift right click like this to add in like a joint for the age and put the age over here. And then we want to say, okay, if the age is equal to 0, so if it's like the first frame that it's alive, it should do this one, like the position that we assign it to. Otherwise, it should always stay the same. It should always stay this one. And to say that it stays that one, we want to make it simulated. So let's go into the simulation output and let's create a endpoint velocity attribute right over there. And let's change this to a vector. And let's also put this one up so that it's above the age. And then to make this go cyclic, I want to make it that over here, the endpoint velocity should go into the true value of the switch node. And the switch node should go into the endpoint velocity of the simulation output. And actually, now that I see this, we have to make this one the false one and this one the true one. And then if you press play, you will see it is not tripping anymore because the curves will not change direction. This looks pretty cool. Already starts looking like a creature. Let's organize our geometry nodes a little bit because it's becoming a bit of a mess. So let's select all the nodes that create the velocity or the movement of our starting point. Let's select them and press Ctrl J, and let's name this endpoint movement, something like that. These two, we can do Ctrl J and say this is the H tracking. And then this one, let's do Ctrl J, and that's the start point movement. If you do not want to make it that your creature makes such huge steps that it goes like from this one all the way to this one, you can limit the distance that it will crawl, so to say. And we can do this by filtering out points in this that are too far away from it. To do this, we have over here in the geometry proximity of this point, we have the distance value, and we can say, okay, if the distance is less than a certain value, if you do Ctrl Shift click, you can preview this like this. And if you make the less than value higher, you will see these points are close enough. But I kind of want to reverse this, so let's make it greater than, so that the black parts will stay there and the white parts will be removed. Now to combine this with our isHit attribute over there, we can add in another math node, place that over there, and we want to add to the isHit, we want to add this greater than value, like this. And now only points that are close enough will be selected randomly. Let's connect our join geometry again to see what this looks like. That looks like this. Perfect. Let's make these curves a little bit more organic looking so that they will more be like ropes or like slime things instead of just like straight lines, right? So I want to make it that points that are like over here are more going to be hanging. They will be affected by gravity. However, those points are not there yet. We have to create those points. So let's go over here into our curve line and let's do a resample curve node and let's do 10 points. That's enough. Now to have control over just those points, we can go over here and create a new set position node. Put that right over there. And to make this set position node only affect the middle points and not the outer points, we can do a endpoint selection. And if we connect that like this, now it's only affecting the endpoints. But to reverse this, we do a map range node. We set that right over there. And right now it goes from 0 to 1, but I want to switch this that it goes from 1 to 0. Let's make these middle points affected by gravity. And to make them affected by gravity, I want to create a new socket or velocity over here. So click on the simulation output, click on the endpoint velocity, click on plus to create a new attribute and name this middle point velocity. And then make this vector and then we can get started. To the set position offset, I want to connect from here our middle point velocity. So let's take this one, go all the way in the end, and let's connect it with the offset. Now to manipulate this that it is affected by gravity, let's do Shift A and a vector math node. And in this vector math node, let's set the z-axis on minus 0.04. For example, let's see what it does. We'll see it will start falling down, something like that. It does work. However, we also have to create the physics, like the rope physics to it. We did this before in my bridge tutorial, so we're going to do it again over here. If you add in a position node, we have the position of each point, and we want to blur this attribute out over the whole curve. So if you set this from float to vector, connect this one over here, and I want to subtract the original position from the blurred position with a vector math node. Like this, set this on subtract, and subtract from the blurred position the original position. And then to add this in on our velocity, take this vector math node, Shift D to duplicate it and add it to it. This already looks cool. However, since we are creating kind of like a slime monster, I think the rope should be a little bit more tightened up. So to do this in the blur attribute, you can set the iterations on 10 so that it will be blurred out even more. And you're getting something like this, and that looks cool. You also see something happening like this, right? That's because these middle points are not going immediately to this original point. Remember that we created that the endpoints are after 30 frames, they are going back to that point. I want it to happen for the middle points as well. So let's literally copy this greater than node and this switch node and this scaling node and this subtract node and this position node and this geometry proximity node. And let's press Ctrl Shift D to duplicate it, but keeping the connections with them like this. And then to ungroup them from this frame, let's do Alt P and let's put this right over there. And then let's make some space like this. I now see we should switch this. So let's put this one over there and this one over there. And then as the false, I want to set this vector math node like that. Then connect this with the offset and connect this switch node with the middle point velocity like this. And then you see it really starts looking like a spider that is crawling around. Pretty cool. Let's take the nodes that control the middle parts and let's press Ctrl J to make a frame for it. Let's name this middle parts movement and let's make some space. Let's test it out a little bit. So if I go to frame 0, if I move this empty like over there, then you will see it will start from there. That's good. And it will like crawl around. Perfect. I will actually now in the wrap node over here set it on 30 so that we have a little bit less points, more like this. And then also we want those curves to go back a little bit later. So over here in this greater than node, let's set this on 100. And in the second greater than node right over here, let's set it also on 100. And then we should have approximately 4 curves at the time. That goes a little bit too slow, so I'm going to set the minimum value over here on 15. And I'm also going to increase the distance that it can travel a little bit. Over here, I'm going to set it on 9. Okay, if we take a look over here, if I press play, you will see, oh, our curve, our tentacle is going like inside of the object. Let's make it that these things actually have collision to it. And for that, I want to get the position of the closest face of each point on the curve. And to get this, let's do a collection info again, and let's set the collection on targets. And to get the position of each closest face, we want to realize the instances. And if you do a sample index node, and we set this from float to vector and from point to face, because we want to have the face data, we can connect the realized instances over here. And now that I'm thinking, I told you that we're going to take the position of the closest face. I actually want to have the normal of each face so that we can push it out along the normal. So with the normal, we can place it over here and connect it like this. And to get the closest face, the index of the closest face, we can do a sample nearest node. And we set this from point to face. Connect the realized instances with that, and the index is going to be the index. And now we have the normal of the closest face of each point of the curve. To make this affecting the velocity of our curve, we're going to make a little bit more space over here, just like that. And then we want to insert a mix node, which we're going to set on vector. Vector B is going to be the original velocity, and vector A is going to be the normal direction of the closest face. And then let's connect this with the offset and also with the middle point velocity. With the vector, we're going to say if the point is close enough, then it should be affected by the normal. Otherwise, it should not. So we want to get the distance from each point to the closest face. We can get this with a geometry proximity node. Place that like that. Let's not connect the collection info with that. Instead, let's connect the realized instances. And we want to put the distance into the vector, so that the closer it is, the more it will push it away from it. And then if we go back a little bit and we press play, that's obviously not working because we have to reset the simulation. And you will see, that's not really looking good. It's not looking good because the effect of the normal is too strong. Let's do a vector math node, set this from add to scale, and let's scale this by 0.1. Then it should be that it's working a lot better. This collision part that we have created over here, I also want to do this on the point that we have in the middle, because I don't want that the point goes like inside of it, right? So let's do that. We don't have to copy all of this. We don't have to do that. We can just take this mix node, right? This, Alt P to separate it. And we want to connect to vector A, the scale node that determines the closest normal. So drag this one to here, connect it with vector A. And for the vector of the mix node, we also want to have the distance. So let's take this one and connect it to the vector. And to make this manipulate the offset of the set position, I want in the simulation output to have a new attribute, which is going to be the velocity of the point. So let's click on the point over here, click on plus, and name this center point velocity. And let's make this a vector. And then in the offset, we want to connect this with the center point in the beginning. So like this, like that. And then let's do shift right click this one to make like a join over there so that we can connect this one easily to the center point velocity. To make this mix node easily affect this purple center point velocity, we can add in a vector math node and connect this like that. And then the point also will not collide with our objects. From here the physics is done. We're going to do some cosmetics. Now we're going to make it actually look like an alien creature. So first thing that we're going to do is making these curves actual meshes so that they have thickness. We're going to do this by first making some space over there. And let's do a curve to mesh node, connect the curves like this, and let's also disconnect this one and connect the curve to mesh to that. As the profile curve, we do a curve circle. We connect that like this, and the resolution of the curve circle can be 16, for example. Let's also make them closed, so let's do fill caps. I kind of want to make it that it goes like this, that if this is a curve, that the thickness goes like this, that it's like thinner in the middle and thicker on the ends. To create this, let's do a set curve radius right over here. And as the radius, I want to do a spline parameter node. And with the vector, if we put it into radius, then you see it goes from smaller to bigger. But what I actually want is that it goes from bigger, smaller to bigger. To create this, we can do a float curve right over here. And then we can create the shape over here. So if we put this one like this and this one that, and then we drag down the middle part, and you see we're getting thicker, thinner, thicker. And what we want to do now is we want to put a huge icosphere like in the middle right over here on this point. I want to do an instance on points nodes right over here on the point that is in the middle. And as the instance, I do an icosphere and I set that this, and then we have an icosphere. Set the subdivisions on like 2, something like that, and you can change the radius to be bigger or smaller, just whatever you like. I like it like this. And now to merge this all together, we can remesh this whole thing. So if you do a mesh to volume node, so that we make this whole thing a volume, and then we do a volume to mesh node, then we're getting it like this. Let's give it a little bit more resolution. So in the amount over here, let's make it size, and let's set the voxel size to 0.05. You will also see the ball and the curves are not really that merged together. That's because this thing is still an instance. We have to do realize instances, otherwise it won't work. And now it's really like merging it together. You can still play around with like the thickness of it, like this and that. Yeah, cool. Maybe a little bit less on the end. Now it looks like this. But if you want to make this look a little bit smoother, what you can do is smooth out the position. So if we do a set position and then we do a position node and we blur this out with a blur attribute, and we set this on vector, we connect it like this. And if we now connect it with the position, then you'll see it becomes smoother. Let's set the weight a lot higher to like 10, and let's set the iterations on like 22 or something like that. And then we're really getting slimy thing. And then you will see when you press play, our creature really starts to crawl around. It really looks like a creature now, some alien thing. Pretty cool. The only thing that I would do is making it shade smooth. Let's do a set shade smooth node right over here to make it look smooth. By the way, if you start seeing that your character is a little bit stuck, to fix this, we want to add in more randomization in the choosing part of the points. You can do that over here, and as the seed value, we do a scene time node. If you set this frame over here, then you will see that problem will not really happen. To improve the performance of this geometry nodes a little bit, we should delete the curves that already went back, because now if a curve goes back, it is still there and it still does calculations for it. But if we just delete it after a while, then your computer will like your geometry nodes way more. So if we go over here after the switch node, if we do a delete geometry nodes, and as the selection we do a compare node, and we set this from float to integer, we can set as value a, we set the h value of each curve, and right now every curve goes back after 100 frames. I will make it that after 105 frames it will get deleted. And then if you connect a result into selection, you won't see a visual difference, but your computer will just run it a lot better. Let's now create a nice little material for this thing. So let's split our screen in half so that we can open up the shader editor. Let's press N to make that pop-up go away. Let's click on our object. Let's also uncheck this pin over here. And let's click on new to create a new material. Let's name this like slime or something like that. Let's also go into material preview mode, and then let's also assign this slime material to our object in geometry nodes like this, with a set material node set to slime. And now if we change the base color to green, for example, it will become green. Actually, for creating this material, I want to go into render view mode and also into cycles. So let's do EV to cycles. Turn on your GPU if you have one. I will also add in a light. So let's do light, point light, and let's set the strength of this light a little bit higher. I want to make this look like jelly. So in the principal BSDF, we're going to the transmission, and we're going to set the transmission a bit higher to like 0.3. And let's set the transmission roughness to like 0.5. To make this more visible, let's put an object inside of this that is like glowing. And to do this, let's go back into our geometry nodes and let's take this instance on points and the realize instance as well. Shift D, put the points into the points over here. And then we want to do a join geometry all the way at end this, and we want to join this one over here, and we're going to make this a little bit smaller like that. And then we create a new material. So over here in the material properties we have slime. Click on plus to create like the emission object. Let's do set material over here, emission. For the emission object, let's do principal BSDF gone. Let's do an emission and let's set that on 100 or something like that, and then you see we're getting emission. That looks really cool. Now to make this look more like alien slime, let's add in like a noise texture, and let's do Ctrl Shift click on it. Let's add in a texture coordinate node and a mapping node by clicking on the noise texture and do Ctrl T, and let's set the texture coordinate on object. Let's set the detail all the way to 0, and let's bump up the distortion a little bit to 1.5. Let's do a little bit less scaling. So let's do a scaling of 2. And then to make a little bit more contrast, let's do a color ramp. And let's bring the contrast down. You want to have softer edges over here. You can set it from linear to B-spline. Then you have a little bit more control if you add in like a new point, and we set this on black. Control over like fading. Now to make this manipulate the base color, let's do Ctrl Shift click over here. And let's do a mix color node. Let's do Ctrl C on the base color, Ctrl V on the color A, and we want to multiply this color so that it becomes darker on certain points like this. Set the factor all the way to 1, then you see it becomes completely dark. Set it a little bit lower, maybe set the noise texture scaling back on 5. You can play around with this. I like it more on 2, maybe a softer edge. Another thing that I'm going to do is set the roughness all the way to 0 so that it becomes a very reflective thing. I do think the emission can be a little bit high. Let's do 1000. That's cool. So that's it for our walking creature. If you like this video, please give it a thumbs up. Comment down below if you have any questions, and if you don't want to miss out on any future video, you can subscribe to the channel. And by the way, if you ever need help in your Blender project, you can hit me up on Fiverr so that we can plan in a personal lesson. And with that being said, I see you in the next one.